My name is Bill Mold, and I'm going to be the moderator. And I have three panelists on the stage: Lauren Mason-Gear, and Chris McCown, and Ricky Buell. Now, what we're going to do is we want this to be a two-way discussion, not all just coming out of us. We're going to start off with some questions which I think are the typical ones that you would come up with if you had a chance to think for a couple of minutes. But then we're going to get done with that, and that will generate some thoughts and questions in your minds as we go along, so you can just jot them down. And then there will be a long period of question and answer involving you folks. So we're going to be talking about wheels and all manner of things that are pertaining to wheels are subject to be brought up by you if you want to. Bicycle wheels at the 10,000 foot level look like a fairly simple structure, but at the detail level you realize when you start studying them that they become unbelievably complicated, but along with that they become extremely interesting and challenging to understand them in their fullest. Okay, so first question is going to be this one here. And I'm going to refer to Chris to answer this one. Why do we build bicycle wheels instead of just buying them for our customers? I could buy them from Trek, I could buy them from any number of companies. Why would I envision wanting to build them?
Yeah, it's a great question we get asked a lot. And basically it's the simple answer is you can customize the wheel to your ride, to your riding style, to the way you ride, to your size, to your weight, to your torque. When you look at, if you go into any bike shop, the same wheel is on the same bike, whether it's an extra small or an extra large. So it's basically giving you, if you want to go running, saying here's a size 9 shoe, go enjoy. It doesn't matter if it fits or not. So for the larger rider, we can build something a little stronger, a little stouter. For a smaller rider, something a little more lively, a little lighter weight. It also lets us address questions like, where are you riding? What do you want to ride? And then we can dial it in a lot tighter. It also allows us to control, when we're working with one individual wheel, we can control quality a lot better and take our time with it. So that's pretty much the basic of it. But
Basically, we can do a better job.
yes.
Quite honestly, we can build a better wheel than you can buy. All right, now, next one. And this is to Ricky. What are the pros and cons of brass nipples compared to aluminum nipples?
So let me think. Let's start with the pros of an aluminum nipple is it's lighter, which is always going to make a difference, being that it's at the farthest out point on the wheel. That's going to have the most effect on rotational weight. The other nice thing is that they're, you can get them in a bunch of different colors. You can customize your wheel, give it that little extra personality. A downside that I have personally experienced many times working in service is that aluminum and carbon react very, almost a toxic reaction where the aluminum essentially will kind of corrode a little bit more rapidly, and then eventually, if you don't notice that, the spoke and the nipple will have no head to it and literally pulls through the rim, which can be kind of catastrophic if if the wrong spoke nipple fails, or it can just ruin the rim sometimes. And so that's, brass. The beauty of brass is that it really doesn't have that reactivity with carbon, so it's really nice and safe to use with carbon, but it's also just a stronger material. It has a much longer fatigue life. Anytime somebody's wanting something built that they want it to be a stronger wheel altogether, or just a more reliable wheel altogether, something that's easier to tune up and true down the road, the brass is just much better for that. It doesn't tend to deform. It won't, like I say, it doesn't really corrode and have those failure issues. In some cases, when somebody's building a wheel with aluminum nipples and they don't get the spoke length quite correct and it's a tad short, I've seen the nipple heads on alloys will actually just kind of pop right off, just because they're not supported enough, and just that material will fatigue a little quicker, whereas I can't honestly say I've seen a brass nipple do that. they tend to just, be a much better choice for just a longer lasting wheel, in my opinion.
That's one of my pet peeves, actually, is what Ricky just mentioned. If you work for a bicycle company and you have to build thousands of wheels to put on the bicycles that your company makes, you would think that you would say, okay, I am going to sit down now and I'm going to calculate the spoke length that I need for this wheel, right? So you do that. Now, if you're planning to build 1,000 wheels like that, you think you might make one and see if you got the length right before you build 1,000 of them? And you might think, oops, looks like I miscalculated. My spokes should be 2 millimeters longer. But apparently that doesn't get done. So 1,000 wheels get made with spokes that are too short. And as Ricky said, if they have aluminum nipples on, the heads are going to pop off. And that is going to be an expensive and time-consuming repair that should have been avoided in the beginning. Okay, next one, back to Chris. What is the best truing stand to buy? This is obviously a matter of opinion, but people on websites argue about these kinds of things. Do you have anything you want to say about that, Chris?
Yeah, so I mean, basically, it's dealer's choice, whatever you're comfortable with. And a lot of it is whatever you get used to using. The truing stand that's in every bike shop is the Park TS 2.2 or TS4, whatever it is right now. And I have a 4 right now because my understanding is that's the only one you can put a 197 hub in at this point.
Right.
So I have one of those, but personally I use the stand in the middle, which is a Centermaster out of Germany. So for me, building wheels is a quick in and out, so every time I want to pull it out, flip it, stress it. And it also has the gauges on it, so I can see how far my lateral and vertical runouts are, and allows me to get it very, very tight in tolerance.
So they all do the same thing. Some of them are way more expensive than others to do the same thing just as well or better at a lot less money. In my case, I would argue that the Park 2.2 right here, this is the one I use every day, and if somebody offered me one of these over here for free, said you can have this, I would say thank you very much, I would take it. But I probably wouldn't use it, I would still use this one because it is my preference. But it's my preference. It doesn't mean it should be everybody's. Okay, next one. This is going to be Lauren. We have a couple slides here. What is the relationship between rim width and tire width? There obviously is a relationship. And so if somebody says to you, I would like you to build me 2 wheels, the first question out of your mind should be, what tire are you going to use? Okay, Steve.
So simply put, the wider the tire someone wants to run, the wider the rim should be, within reason. So various reasons for that, but I always like to bring things back to user experience, right? So like the question beyond, like below that might be, what do you want to do with your bike, right? So the big thing right now is gravel riding. So, but that can mean a lot of different things. So someone that's riding like a mix of pavement and gravel, for example, like they're going to want a mid-width rim that can have, like, you're looking at a range of tires for everything, but you want to make like the range kind of like a sweet spot within the rim that you choose. And so what you're going for there is the way that the tire profile ends up once mounted. So you can imagine if you have a very narrow tire, a very narrow rim, and you put a big tire in it, you're going to end up with a bulbous profile there, which when...
Like this one here. That's
yeah, exactly. Like that would be an extreme example.
It's like a
sure.
light bulb.
And as you can imagine, the forces on that when you're going around a corner makes that tire want to roll, right? And that's going to be like an unpleasant ride. It's also going to pinch flat much more easily. You hit something from the bottom there, you have more tire hanging over the edges that's going to want to pinch and create punctures.
Here's a couple more graphics.
Yeah, perfect.
The bad, and the good picture.
And then, but you could go to the too far extreme, right? So you could make your rim very, very wide, and then it has too narrow of a tire on it, and now you have something that's entirely square. And a bicycle tire has knobs on it. For off-road, bicycle tire has knobs on it that you want in particular spaces. So if you make your tire completely square, you could have knobs that are designed to be side knobs, say on a mountain bike wheel, that now are completely flattened. So you don't have those, like what should be creating traction for you. And then lastly, of course, there are safety precautions, and you should always follow the rim maker's suggestions of what pressures and tires should be on there. And the wider the tire you're putting on something, the bigger the tire, the lower the pressure should be. And it's very important that you adhere to those guidelines. Most tires will all say on them a tire pressure that like the maximum tire pressure and whatnot. Your rim also has that. And the rim, I don't want to say trumps it, but that's the only word I can think of. So that's what rules the roost in that situation. You want to adhere to the rim manufacturer's suggestion of tire size and pressure on that for safety reasons.
Now here is a handy chart. If you go to the Velocity website, you will see a graph like this. And so this is really, really useful. So if I'm going to use a Velocity rim, and I'm going to use, say, a 2-inch or 50-millimeter tire, I just drop straight down, and it'll tell me what rims of their brand are appropriate for that size tire. Now, what I did was last night, modified this by putting, for each of these tires, the inside and outside thickness of the rim. And I'm going to ask Velocity to incorporate this into the one that's on their slide. So if I have a rim made by Bill Mold Industries, if there were such a company, and I know the dimensions of it, I could come out and say, oh, those dimensions are just like the aileron, and so these are the appropriate tire widths that I would use. So that is a really useful chart. If you're a wheel builder, you pull this up and it gives you a lot of information right off the bat of a good tire to go with a given rim in its dimensions. Okay, next. What is the relationship between the number of holes in a rim and the crossing pattern? And Ricky, this one's back to you. This is going to be kind of a tricky thing, and I'm going to put up this next slide here.
What was the relationship of
the
spoke count and crossing?
Spoke count and crossing patterns.
Most wheels we encounter, it's, the way the crossing pattern works out, it kind of affects how your torque is transferred through the wheel. So you look at some of these complete built wheels, they have radial spokes on the drive side, which maybe is great for tension, but those spokes, because they're coming straight and then the forces are coming at an angle, those spokes tend to have a lot more wind up as that hub is getting torqued. And so that's not a really ideal lacing pattern for a wheel where you're trying to transfer a lot of power. So as you start getting more crosses into the spokes, those spokes have a more direct line with that drive force. Most wheel sets that I deal with, they're 28 to 32 holes, and they're almost all 3-cross. Occasionally we'll get some 2-cross 32 hole and 28 hole wheels in. They're not necessarily any worse. People seem to have no problems with them, but you could argue that it's not an ideal of a lacing pattern. When you get into the even higher spoke count wheel sets, the hub flanges tend to get a little bit bigger, and then you have the opportunity to go to a 4-cross, which really makes for a fairly robust wheel. That's something like if you were building a tandem, or back in the day when people were building free ride wheels that were supposed to be hucked off of an 80-foot cliff. That was a good setup because it was just so strong and durable. But like Bill's slide here, it shows there's actually kind of a formula you can kind of use to help you decide whether a 4-cross is ideal, or if you should be doing a 3-cross or 2-cross. I would say 3-cross is always going to be the best choice. It'll work on pretty much any spoke count, 28 and up. Although I have seen some 24 spoke wheels done 3-cross, but those are kind of an extreme case. But what you can run into if you tried to run a 4-cross, which I've done in the past in my early wheel building days, like took a regular pair of Shimano 32 hole hubs, tried lacing them 4-cross, what you end up the problem you have is that because the spokes are kind of coming at such an extreme angle, they end up almost like laying over the neighboring spoke's head, and so that, you know, eventually can lead to a spoke failure or just not really
Yeah,
build up
spoke
great.
failure, you have to disassemble half the wheel to be able to replace it.
Yeah.
So this rule of 9 here, the minimum number of spokes for X crossings is X times 9, rounded up to 4. So just as an example, if you want to use a 3 cross, 3 times 9 is 47, rounded up to 28. 28 spokes is the minimum number for which you could use a 3 cross. So that's a handy little equation, and it's generally correct. Okay, on to the next one. And Chris, this is back to you. Why do many wheel builders measure ERD instead of using published data?
Sure. So real quick, for ERD is basically the distance of the rim diameter. So I measure every single time, basically because in the extrusion process, it can vary from, you know, a millimeter or 2. That has gotten significantly better, I've noticed, with the advent of tubeless tires and tubeless rims. However, I don't trust manufacturers' ERDs because they may not measure the exact same way I do. So my measurement is the exact same every time. So when I'm calculating my spokes and running my numbers, my ERD number that I measure is my ERD number. I've measured it. My spokes, my sticks that I measure with are my sticks. So if there's any sort of variance in there, we can come up, you know, I built a wheel the other day that my ERD was 5 millimeters off of the published ERD, and my spoke length was perfect. So if I had used that, I would have been wildly off and forced to rebuild that wheel. So I always advise everybody to measure their own ERDs every time, just because it becomes part of your process, and that number is yours. So it's your measurement, it's your way of doing it every single time.
Absolutely. I think you can trust the measurements of hubs.
Yes.
Hub flange diameters, the distance from the hub flange to the middle and things like that. But don't trust ERDs. How long does it take to measure the ERD of a rim? Maybe 5 minutes. Once you know how to do it, it's very fast. And if you make a mistake and you use the wrong ERD, it takes a long time to disassemble the wheel and then do it all over again. So the time saved in measuring the ERD, making sure you get the correct spoke length. I don't know anybody who builds wheels who will trust the ERD that's printed maybe on the rim or on a website.
I should also mention you want to measure it in 2 or 3 different places in that wheel and take the average.
Okay, next. This is for Chris again. Why do I need to use a tensiometer when I can just plug the spokes and hear the frequency? Why isn't that good enough?
So you don't get an actual data from that. You don't get an actual number. We're shooting for kilograms per foot of force, and that's how we measure. Plucking the spoke and hearing that frequency is not going to tell you anything. I don't have perfect pitch, and I even think people that would have perfect pitch aren't going to be able to correlate that pitch to a mathematical number. So by doing it with the tensiometer, we can balance that wheel out very well, which is really crucial to a well-built wheel, is a balanced and even tension. So this gives us numbers. Depending on what tensiometer you want to use, even the Park one, which I think we all use this. When you first start building, it's like a $60 tensiometer, but it does its job. I still use one for the first part of my building until I get to about 80% of my tension, and then I switch to something that is gives me a little more accuracy. But you'll hear people talk about, oh, I just pluck the spokes and I hear and you can kind of balance it that way. You can certainly find a loose spoke that way, but I would not build a wheel that way.
Right, so plucking can tell you something about consistency of tension, but not magnitude at all. So people say, well, I build so many wheels, I can just tell by feel. Baloney. It is not doable any more than you could go over and squeeze a tire and know how much pressure is in the tire. You can't do it. You have to measure it. And any tensiometer at all is way better than none. And the Park one, as Chris said, is pretty good place to start. Now, this is the last of these, but this one is for Ricky. What is the difference between stress and wind-up? These are two things that you deal with when you're building a wheel, is relieving stress and eliminating spoke wind-up. There is a great deal of misinformation about these. They're not the same thing at all. Okay,
Yeah.
Ricky.
You know, typically throughout the build process, you know, as your tension's coming up, the spoke head or the nipple is, you know, going to start kind of bedding in and settling into that rim. And so something that's kind of important to just kind of really help keep everything evenly settled in is, you know, going through, grabbing those spokes and kind of giving them like a really good squeeze, and that kind of, like I say, kind of helps bed them in a little bit. You know, sometime like at Industry 9, we have a pneumatic press that will actually, you know, the rim is supported, the hub gets pressed down, so it kind of does both the stress relieving and kind of gets rid of some of the wind up, because it's putting a bunch of tension on one half of the wheel and relieving the tension on the other half. But you know, also through the wheel build-up process, you know, the nipple or the, you know, the spoke being as long as it is going to start to kind of, as you're getting tension, it may not want to just let the nipple spin, and so the spoke kind of goes with it. And so you could sit there and turn the spoke or the nipple at the rim, but the threads are kind of moving in unison. They're not moving separately of each other, so you're not actually adding or removing tension as that stuff is winding up. And so that's another really kind of important thing, is, you know, a step is to try to sit there and eliminate that spoke wind up so that you can actually get the wheel tension and you know, built properly. Something that it happens even with our big stiff aluminum spokes, where I basically have to sit there and spin it at the rim, but then I have to feel with my finger to just ensure that the spoke is actually spinning its entire length. But it happens, you know, just the same with steel spoke wheels. So it's, you know, and especially once you start going to like a thinner gauge butted spoke, that wind-up effect is amplified by that thinner material. And so it's even more important then to really do that wind-up, you know, kind of relief process, and, you know, before you're finished with the wheel. You know, and then as you, because I guess if you don't do that, once you start riding it, the wheel, everything's going to settle and move more, and then, you know, the wheel may come out of true, may lose tension, you know, won't be as solid and stand, you know, like it should.
If you ever are riding on a freshly built wheel and it starts right here, ping, ping, what you're hearing is the wind-up coming out of the spoke. And that can be unnerving. If you don't realize what's happening, it could be kind of scary for someone who is the uninitiated type. So here's a picture of the process to eliminate the wind-up. Now here is a website, a guy named Fleming, who goes by the name of Mr. Rabbit. I'm not sure where that comes from, but he's out in California someplace. But if you look up that website, Wheels by Fleming, you'll find a really good 16-minute video that explains in some technical terms why it is that you have to do stress relieving and what actually is happening when you're doing the stress relieving. I've really a really good video. Okay, now we're going into questions that are from you. So anything you have, there's no such thing as a dumb question, by the way. And so any questions you have on these topics or anything related to wheels, you can fire off, and we'll do our best to try to answer it for you. Yes, sir.
Spoke calculators. Do you use online spoke calculators? And if so, which ones do you recommend?
Yes, I do. I use United Bicycle Schools.
Bicycle?
It's consistent. It's, again, it's back to my process, so I know what.
Use the same one over and over? You
Yep,
know what you get.
exactly. DT has a great one too, and I'll use that one to get their hub dimensions. There are several others out there, but United Bicycle is the one that I use.
Quality bicycle products, if you're a dealer, has a good one also. I think they're all good. And I think using the same one all the time is probably important.
Consistency is key.
Because then you get to know, you know, if you're going to do some rounding up of length, you get to know for that wheel and for that calculator how much rounding do I want to be able to do?
I use the DT Swiss one, which seems to work pretty well for me.
Yeah, I think all of them are good, but again, it depends on the accuracy of the ERD data that you put in. If you put in the wrong ERD, you're going to get the wrong result with any of them. Yes, ma'am, you had a question.
What direction would you suggest somebody that wants to work in the building industry? Because I want to be a little, but I don't know where to start.
Bike shop,
Yeah.
What if they don't want to hire you because you don't have the experience?
make them. No, that's a great question, though. There
The
are,
question was, what do you, if you want to become a wheel builder in the industry, how do you get started, pretty much?
there are schools, United Bicycle, you can go and take a class there, and I think that would, I think they've got a 3 or 4 day course that would put you arms and legs above anybody else applying to a shop. But just keep applying, keep watching videos. Bill has a lot of videos out that have a ton of information in it. So I was fortunate enough to learn in a shop that had a strong wheel builder. And he taught me, I started learning by doing rim swaps. And lacing is actually the easy part, and which I thought was the hard part. It's getting that tension dialed up. There's a lot of great videos out there. Just ask as many questions as you can. If your local shop doesn't want to hire you, just be like, hey, can you teach me how to build a wheel? And a lot of, particularly in the winter, I'm from northern New England, so in the winter we're always looking for stuff to do. So we'll run a lot of wheel building classes, and a lot of it is, I did one a couple years ago with 6 classes, and you walked out with your own hand-built wheel set. So things like that. Finding a mentor is, the best way to go, I would say. So just make sure they're good.
I teach a two-day school in my shop in Alexandria, Virginia, and you build a set of wheels that you're going to take with you. And I spend as much or as little time on certain topics as the student is able to absorb. So you can teach wheel building in terms of concepts or deep into the technical aspects of it, depending on how well your student is going to be able to understand some of the more technical things.
Find a junk wheel, take it apart, and put it back
I was
together.
gonna say,
So build a whole bunch of wheels.
yeah, it's not.
And it's made out of a bunch of pieces, right? So there's no rules against taking it apart and putting it back together.
yeah.
So
It's,
the-
Need tools.
Yeah.
Yeah.
Well,
Yeah.
so the little trick is what we do is not hard. It's pretty easy. It takes a long time to get good at it, and it takes a lot of attention to that detail. And for me, finding that balance in the wheel is very calming to my brain. So yeah, go. If there's a junk bike sitting there, just pull its wheels and sort of look how it's put together, take it apart, and put it back together. So buy a spoke wrench and just use the fork of the bike to start with.
yeah.
One thing I've noticed after building a lot of wheels and having wheels come into the shop that need to be adjusted and tensioned that are absolutely in horrible condition. So you can, as long as a rim is not bent and the spokes are the correct length, you can't do anything to the wheel that is not reversible. So if you try to improve the wheel and you're tensioning it and you make it worse, all of that can be corrected. So it's a methodical process, but it's not something to be feared. So you can't experiment trying to build a wheel and say, well, this wheel is beyond repair. It isn't. It's fixable, but it may take a lot of time to fix it. So one way you can start out, if you were working in a bike shop as a mechanic, mechanics work on wheels. At the very least, when somebody brings a bike in for a tune-up, they get all kinds of adjustments and things like that. But included in that is truing and some amount of tensioning of the wheels. So you start getting used to working on wheels just by being a mechanic and doing tune-ups. Other questions? Yes, sir.
Maybe a little off topic, but do you have any opinions or comments about hookless rims and versus hook bead rims? I've done 45 years, and what was new and better is now old and not better. The cyclic nature of our industry is sometimes very disappointing. in product development. So that's my opinion. I'm curious about your opinions.
I mean, I've got an opinion on this. What do you
Go
guys?
ahead.
So all my wheels are hookless, and part of that goes to, with the advent of tubeless tires, our rims have gotten so much tighter tolerance, and our tires have gotten tighter tolerance. So as long as you're not, doing something really outside the box, like I've got a 20 millimeter ID rim and I'm trying to put a 2.3 mountain bike tire on there, it's not going to blow off. So going back to Lauren's point, as long as you stay within that manufacturer's recommendation for that rim, hookless is no problem.
Yeah, I mean, most of at least our mountain bike rims are all hookless now, and I mean, the only time I've ever heard of somebody blowing a tire off was because they put 60 PSI in their, mountain bike tire or whatever, and so they just completely annihilated the thing. But, most of the road stuff is still hooked, at least, and that I don't know too much hookless road stuff, but yeah, I don't think there's, necessarily a bad thing, one's not any worse than the other, but
gotten smaller.
the hook is nice. Just if I'd say if you're just still running tubes, the hooked rims are still kind of the way to go.
I'd say super high pressures. I'm more comfortable with a hooked rim. But they're out there and they're certainly working for people, but like that's where, but for a hookless mountain bike, yes, things come in cycles, we see things in our industry that emerge and come back, and sometimes it's just the same thing, and sometimes it's that we can do something better now than we used to be able to do it. And I think a hookless carbon rim is an example of that.
The tolerance control
Yeah, exactly.
is a key to why it's working as well as it is. Yeah.
Exactly.
There is a problem within the industry, though. It's an international problem.
Yeah.
Because if I have a 700C rim and I put a tire on that is the appropriate tire for that, I should not have to worry about the tire blowing off. But maybe it does. And then I call, let's say it's a Velocity rim, and I call Velocity and say, this tire blew up. Well, that's not the best tire to use with that rim. If you use this tire, this Schwalbe tire is better. That's not good. That's not good from the industry standpoint. It should be, things should fit together better than that. I'm on a committee, ASTM is an international organization, mostly of engineers. I'm on the wheel committee of ASTM, and we're talking about this all the time. And so everybody knows there's some type of a disagreement at the detail level of tolerances, but we don't have it fixed yet. But it is an industry problem.
Well, that also speaks to the difference between labeling and dimensioning in what is being put on a piece of paper or the sidewall of the tire or the rim.
Yeah.
Labels are not necessarily the measurement.
Okay, any other questions? Yes, sir.
I've had situations where people building wheels for me didn't want to reuse spokes. Is that valid or is that not valid?
I think it kind of depends on the history of the wheel. If that wheel had too low of tension, for a while kind of thing, what happens when you have too low a tension on that J-bend spoke is as it's going through that detensioning cycle, you're getting a greater, more exaggerated kind of detension, almost snap elastic. So that head of the spoke is just kind of moving way more, and so it can be closer to that end of its fatigue life, if you will. And so a wheel builder taking on that wheel from you doesn't know what the tensions maybe were, so they don't want to rebuild you a brand new wheel and have you go out and 2 rides in have spokes start popping. So I think that's the main reason why most wheel builders wouldn't want to reuse their spokes.
It's an unknown for us.
Right. Like my girlfriend has a lovely bike that I recently bought her, but she wants silver rims, and it doesn't have many miles on it. Can I reuse the spokes in that situation?
Depends on their length in that situation. If you go to a different rim, you're likely going to need a different length of spoke. And then those spokes could be perfect, but they won't work in that application. You could save them to rebuild in something else should an occasion arise. But
in which, that's a conversation with your wheel builder of like, hey, these are brand new. If it's possible, I'd like to reuse them, but they may measure it and be like, hey, they're 2 millimeters too short. I'm not comfortable building you this wheel because I don't, for me, when I build wheels, my name is on that wheel, so I want it to work. These guys, like, their company names are on their wheel. They want to trust that wheel.
And I've always taken their advice and not reused the spokes.
Yep.
I've always wondered if they were just trying to make extra money.
No,
Probably
it-
not, because what if we're swapping one rim with an identical rim? Okay, so it should make sense, so of course I can use the same spokes, absent what Ricky was saying.
Right.
But what if I look at the wheel and I think the spokes are not the right length to begin with?
Right.
So if I'm going to rebuild this wheel, I'm going to use the correct length spokes. I'm not going to rebuild the wheel with spokes that are number one used and also are the wrong length. So there's all kinds of reasons for wanting to use new spokes that are unrelated to, maybe just being able to sell some more spokes. I don't think wheel builders care that much about selling round spokes because they're not very expensive. There's not much of a profit in building a wheel. The profit is in using the hub, the rim, and the labor, not necessarily the nipples or the spokes. Other questions? Yes, sir.
Spoke prep, do you recommend one versus another, especially with aluminum nipples?
This is a frequent topic on
Yeah.
websites.
It's actually in major discussion. So the spoke prep that I use is no longer in production, and I'm a little torn right now. There's a
Argument?
yeah. I'm like, do I spend because it's still on Amazon and it's for like 5 times more than it should cost. Like, do I use it, or I think I know what I want to use next, but again, it goes to I've always used it, so I trust it. I've experimented with others when people have given me stuff that I just don't like. It just doesn't hold up for me.
Because I know one of the reasons is to prevent galvanic corrosion between the nipples and the spoke.
Yes.
And my concern, experience-wise, have you had failures of some of them? If so, which ones?
So again, I live in northern New England, so I will fight you tooth and nail to build you a wheel with alloy nipples. You've got to give me a really good reason to. Simply because there's so much salt on our roads. It advances that corrosion, and those wheels, last maybe a year or two, and it'll just, especially without the spoke prep, that will seize to it. Even with the spoke prep, it will seize. So for me, it's, I have very low stock in alloy nipples, unless, some people, they want a fun color.
I try to avoid them at all possible.
Yes, yeah, that's sort of my rule of my go-to.
The only one person I haven't been able to avoid them is my wife, because she went purple.
Yeah.
It's an issue of religion, really. Like I'm a Catholic, you're a Protestant, somebody else is Jewish, and you argue about it. But we see these topics on some of these websites come up weekly, I would say, and somebody's going to argue for spoke prep. Oh, no, that's no good. I use boiled linseed oil. No, that's no good. I use some. My preference is to use, I don't use any of those things. I lace up the wheel dry and I use self-locking nipples. And then I lubricate the threads a little bit later with some oil. So there's all kinds of ways you can do it. I don't know that one is better than the other, really, at the end of the day.
There's probably some regional wisdom to be garnered from wherever you are. That's probably another reason to go back to the original question of, like, if you're building something that it can be local, because it does matter in that situation. So you might just talk to local folks and see what they're having good success with, because I'm from the Pacific Northwest. We don't know about salting roads, right? So it's like it's a different thing.
Yes.
How do you guys feel about the trend on carbon spokes?
Yeah, I mean, I haven't had to deal with carbon spokes all that much. I mean, to me, my always concern with carbon is, sometimes you don't necessarily see the damage right away, especially with rims. And unfortunately, the failure mode of carbon fiber can be rather catastrophic, whether it doesn't deform, it just breaks, like when people ask me a carbon rim or aluminum rim, I always go back to, you can dent the ever living goodness out of your aluminum rim, and at the end of the, when you get off at the trail, you can put an inner tube in it, ride the thing out, and it'll still kind of function. But a carbon rim, if you smash it and it reaches that failure point, it could be so bad that you can't really put an inner tube in there because you've got, sharp pieces of carbon fiber now sticking everywhere. And, to have that to make a major support structure, or the structure of that wheel out of this material, seems a little, I don't know, I wouldn't necessarily be super comfortable with it. I mean, carbon fiber technology has advanced immensely since it was first being used on bikes, so, you know, I'm sure in most cases it would be just fine, but I would certainly be a little hesitant to want to use it myself.
Your question specifically was in reference to spokes.
Yeah.
So I've done a lot of study on this topic. So you basically have spokes, you have cheap carbon steel spokes on cheap bikes, then you have stainless steel. You can have titanium, you can have aluminum, or you can have carbon. Those are the materials. All of them have pros and cons, but to understand them takes some effort. For example, how about titanium? Well, titanium is pretty light, right? So titanium, it would appear that, well, I can build a really light wheel if I use titanium spokes. Well, it doesn't work very well though, because titanium is pretty stretchy. So in order to get the titanium to work properly, like stainless steel, you have to have a spoke that is thicker. And so whatever lightness you might get out of it goes away because you have to beef it up. And the same thing is true of aluminum. So the aluminum spokes, how many of you know the Maverick Cerium wheels, everybody's seen those, right? They have aluminum spokes in them. But there's a lot of material in those spokes. They're thick and they're wide. So the aerodynamic advantage is lost, really. And at the end of the day, my really strong preference is to always come back to stainless steel. I just think you can't beat it in 99% of applications. I like aluminum rims a lot. I use a lot of them, but I don't like the spokes. Yes?
How about the ultra-high molecular weight polyethylene fiber spokes?
Yep.
The beard spokes.
Sure.
Yeah, bird beard, yeah.
Have you built some wheels with those? Or do you-
Yep. I built 2,
Okay,
and that's where I'm stopping.
okay. What's that?
But that's a matter, if some people like them, I think they're enormously time consuming.
Okay.
It takes a lot
And I
of
don't see the
time.
benefit, but that's my opinion. Other people like them and swear by them.
Typically, you have to modify the hub in some way, you know,
Yeah.
countersinking the spoke holes, which oftentimes voids the warranty on it. So, you know, you're taking a brand new, you know, whatever, expensive set of hubs, and then you're just going to take a drill to them. But yeah, like Bill's saying, they are definitely more time consuming to try to lace up and deal with.
Yeah,
If
and
you
I
want a
haven't
wheel
ridden them
that
enough
is-
to.
That is going to be favorable from an aerodynamic standpoint. You don't want to use round spokes. That's one problem. Those are round. They also aren't particularly smooth. So the airflow around them is going to be not good from the standpoint of the drag coefficient and also the laminar flow of the fluid around the spoke. I don't think it's a good design, personally.
Yeah, just so we're not knocking on Bird too much, I would say, like, if that's your jam, it can work, right? You can, but like we experimented with it. Time was the thing. It was like they would have cost $1 gazillion just in man hours, and they're expensive for sure.
Yeah.
So, but they're light.
Yeah.
I've heard they've got a good ride quality. They're like,
Yeah.
you know, they're lightweight, and they do make the wheels feel, they don't feel as like, you know, if you're going over bumpy terrain, it doesn't have that feeling of like just super rigid, beat you up. It definitely has a very good damping effect. But
You're also going to have a hard time finding someone to work on. I mean, that like really knows how to work on them.
That's
Probably.
for sure.
You know.
Any other questions? Okay, so let's go ahead then into a couple of other things. Hot tips, and I'm going to start with some, and then all of you panel members and any of you, if you have tips that you want to offer that we didn't cover, you can do that. This first one is precautions when working with aero or bladed spokes. Here is what will make you cry. When somebody brings a wheel in, a beautiful wheel, and you see that the spokes have been twisted like that, that is not wind up. That's a structural, mechanical permanent twist in the spoke. And that very much weakens it. So what you have to do when you're dealing with aero spokes is to have a way of holding the spoke to prevent the spoke from being able to twist in the first place. And these are some spoke holders. And these are some more. These are the ones that I think are very good, that are made by DT Swiss. They slide all the way down on the length of the spoke. So they protect the spoke from being able to wind up. Now here are some graphics. The top show the dimensions of a Superior CX-ray spoke. Those are exactly the same dimensions as a DT Swiss Aerolite spoke. So the spoke is, people call it oval. I would rather refer to it as being elliptical, because elliptical has a geometric definition, whereas elliptical, whereas oval does not. Here is for the CX-ray spoke, which has 0.9 millimeters thick. Now, this bladed holder is 0.8 to 1.0. So that red one is the one to use for Superior CX-ray spokes or DT Swiss Aerolites. And this is, in my estimation, the best spoke wrench. It's a four-sided spoke wrench, and it works sideways like this. You can get this from Rick Hurtberg, the bicycle fanatic. He sells those.
Wheel Fanatic.
Pardon me?
Wheel Fanatic.
Wheel Fanatic. And so this is what it looks like when you're working at it. You're holding spoke stationary with a red tool, and you've got this tool here which goes sideways. So the tools don't get in each other's way. So I use these all the time, and I really think it's the best combination of spoke holder and wrench. And being a four-sided wrench, once the spoke wrench is on the nipple, it can't slip off. So it's a great combination. Any questions on that? I have one other one. Okay, so that's worth a lot. If you only get one thing out of this presentation today, maybe that's it. Now, I've come across a website called Grin Technologies. This is a guy that works there. He builds a lot of wheels. They're in British Columbia in Canada, in Vancouver. So if you go to their website, you see places where you can enter data. So let's say I'm going to build a wheel, and I'm going to put in a bunch of data. I'm going to put in my flange diameter, 56 millimeters, distance between the flanges, which is 40 millimeters. It's 28 spokes. Here's the axle length. It's a 700C wheel. I measured the ERD, 580 millimeters, and this is the rim width. Now, the only thing I need to know is the crossing pattern. So I have a choice there. If it's 28 spokes, I have a choice. We talked about that. I can have two cross, or I can three cross. Now let's see what the consequences are. So if I put a three cross down there, there is my finished wheel. It tells me a diagram that shows me the exact scale drawing of the wheel, and with all the angles. So this here is my radius. That's one of my spokes. I have a 6-degree angle between my radius and the spoke. So I have an articulation angle of 6 degrees, which is well within the nipple's ability to swivel a little bit. And over here it tells me the spoke lengths also. So it is really useful to be able to see what is this wheel going to look like. And if I'm curious about how tangent this spoke is to the whole flange circle, I can see right there, it's tangent to it. It's tangent through the whole flange circle. And I say, okay, that's pretty cool. What if I do a 2-cross? Well, if I do a 2-cross, my angle goes down a little bit, so my articulation angle is now 5 degrees. That's a little bit of an improvement. But my spoke is no longer tangent to that whole flange circle. So if I'm concerned about this being a disc brake wheel, and I want to make sure I get good torque from the hub on the wheel when I'm stopping the bike a little hard, this is not going to be as favorable as the other one. So, without going into this anymore, I would just suggest to you that you take a look at that Grand Technologies website. It's really brilliant, and it gives you the exact to-scale diagram of your finished wheel and what it'll look like. Now, I've got one other one here. Do you guys have anything you want to talk about before I talk about spokes?
I mean, I guess the only other thing I was going to offer as a tip or suggestion is if you're just getting into wheel building or, want to start to learn how to build wheels, you haven't done much yet, it's kind of complicated or a little overwhelming because there's a lot of different ways you can lace a wheel. A lot of people, they show a way where you load a bunch of spokes in and twist the hub and load more in and do this. A book that I found really helpful when I was first starting wheel building was this book called The Art of Wheel Building by Gerd Schraner. And the way the book is laid out, he has really nice diagrams or graphics of how to lace a wheel. If it's a 32 spoke wheel, you're doing 8 spokes at a time. And I still do it that way, even though I probably could load a bunch of spokes in. But the nice part about that lacing method is that you're only fumbling, you're not sitting there fumbling with 32 spokes in a wheel and trying to interlace them and mix them. It's just, here's 8 spokes, these go here, flip it, 8 more spokes, they go there, then the other 8. And it's a really nice, simple, clean, and it's an easy way to learn because it's easy to figure out if you put a spoke in the wrong hole. You're not sitting here trying to pick through a million other spokes. It's just a very clean, simple method that like I say, I still do it to this day, and I highly recommend it for learning.
It's a very good book.
It's a
One
great
of the
book.
things in that book also, that Gerd Schraner has built probably tens of thousands of wheels. And he said in his book that he used to build them without a tensiometer until he decided to use a tensiometer. And then he realized how unprofessionally many of his wheels had been built. They just did not have the tension equality or consistency that he thought that they had. So he never builds another wheel without a tensiometer. So that's from a really experienced wheel builder that's been doing it for a long time. Wanted to talk for a second about the advantages of double butted spokes compared to straight gauge spokes. This is a fairly easy concept to understand. At a technical level, it's a little bit more involved. So I'm going to show you one slide, but I'm not going to leave it up very long because there's math in it, and I don't want people to run out of the room. But this is an equation for what's called the modulus of elasticity. It basically describes how much stretching occurs in spokes according to certain properties of them. And basically it comes down to this, and this makes logical sense. If I have a spoke that is thinner and I put a force on it, it's going to stretch a little bit more than a spoke that's thicker with the same stress. That makes sense, right? That's what this mathematically tells us. So here I have 2 spokes, and I'm going to show you a graphic here of a rubber band demonstration that you actually can do with real rubber bands. So I have a straight gauge spoke at the top and a double butted spoke at the bottom, where it's thinner in the long middle section. So I'm going to start by representing 4 small, thick rubber bands. And those represent the thickness of the spokes at their ends. And the ends of the spokes, in both cases, are 2 millimeters, so I have all of those rubber bands looking the same. But now I'm going to connect them. In the first top slide, I have a thick rubber band connecting them because I have a thick spoke connecting the ends. Now, the one under that, I have a thinner rubber band connecting them because I have a thinner spoke connecting the ends. So now what happens when I stretch those spokes, as they go around the wheel and constantly goes through stress cycles. So watch what happens. So what you see is that in the top one, where you have a thick middle section, a fair amount of the stretching of the spoke takes place at the ends. Well, where do spokes typically break? In the middle or at the ends? Where do they break? Ends. They break at the ends. Hardly ever do they break in the middle. They break on the ends. That's where they're vulnerable. So if I can have a spoke where I don't have as much stretching taking place at the ends of the spoke, it takes place in the long middle section where the spoke will not break, then I'm way better off. That is, in effect, the benefit of double butted spokes. Now, the top spoke will have a higher tensile strength. So if I were to attach that top spoke to the ceiling and start hanging weights on it, you know, maybe I might be able to hang 600 or 700 pounds of weight before the spoke would break by exceeding its tensile strength. The one underneath would have a lower tensile strength. Is that significant? No, because no spoke in any bicycle wheel will ever come anywhere near its tensile strength, or we won't even come more than 1/3 of it ever. So the tensile strength is an interesting number, but it has nothing to do with the engineering and the geometry of a bicycle wheel. So that's my rubber band demonstration. And if you take actual rubber bands and connect them, it does exactly what that suggested it would. Okay, so we're at the end of our time, but we have another half an hour if we need it, until the next group comes in. So you can either ask questions, or you can come up when we're done and ask questions about anything at all pertaining to bicycle wheels. Anything else? Yes, sir.
I found with spoke wind-up, with round spokes, I found that the wind-up is a small fraction or significantly smaller when you are loosening. So I've been building wheels around round spokes by doing like a half a turn pass and then loosening it to the point.
Yeah, you can do that.
And I found like it is a lot less wind-up to deal with.
What is a giant pain in the neck to deal with is round, straight pull spokes,
Yeah.
because they just want to spin in place. Until you get some tension on them, you can't use a holder because they're round. Now, there are a couple of holders that have come out for round spokes. Park made one. It didn't work for me as well as I thought it would. So that is, it's a hateful thing to have to do. So, you know, because they just spin. And so getting consistent tension on them from the beginning, equal numbers of turns of nipples, is really hard.
Does anybody think straight pull is an advantage? What advantage do you see?
I don't think so.
I mean, the advantage that people will tell you is that because you're eliminating that J-bend interface with the hub, you in theory eliminate that potential failure point, you know, which, and I guess in my experience, I have not, you know, seen a straight pull steel spoke break at that, you know, junction of the hub. I mean, that's the biggest practical advantage. You know, wheel companies will do it because you can lace a wheel faster. You just throw 28 spokes in a hub and everything's kind of where it needs to be already, so it can be assembled quicker.
You can supposedly replace a broken spoke easier too, because you don't have to take a cassette and the rotor off. But those are kind of, I think, minor factors. Most wheel builders probably would prefer to use J-bend spokes. If the wheel is tensioned correctly, they're not going to break on the ends anyway. So if the head of a spoke breaks off on a J-bend spoke, I'm suspicious that the wheel wasn't tensioned correctly. Yes?
Is there a situation where you would choose a straight gauge spoke over a double butted spoke?
I can't think of one.
Budget.
Always going with double butted.
Yep.
Or
Yeah.
if just the customer has to have, you know, for whatever in the customer's mind, a lot of times they're just like, you know, I want the straight gauge, I want the whatever, this thickest spoke, toughest spoke. In their head, they think that's the best spoke for them, and sometimes you can't talk them out of it. But
That would-
the
that would
practical
be-
application, yeah, I mean, realistically, a double-butted spoke is always going to be a better performing.
That's exactly right. A lot of people, it's reasonable to think that a thicker spoke would be a stronger spoke, but it isn't. It's thicker, stronger in terms of its tensile strength, but that has nothing to do with how it works in a wheel. Then you're talking about those tension cycles. And the double-butted spoke is way better in that way. So I can't think of an instance where, I'll tell you one reason manufacturers will build wheels with straight gauge spokes is because they're less expensive. That's one. So if you see a bike that's got all 2 millimeter spokes on it, it's that way not because it's better or the wheels are stronger, it's because the spokes are less expensive. So you're looking at, trying to save pennies on spokes. That's probably the main reason that they're used. Yes?
Eyelided rims, uneyeleded rims, nipple rim friction, any comments?
A little bit of lube.
Yeah.
Yeah.
Yeah, Phil Tenacious Oil
Yeah.
does,
Yeah.
does
Brass
well.
nipples will self-lubricate a little bit more than an aluminum nipple. We'll try and bind a little bit,
Yeah,
but
foul up a bit.
yeah, just a drop of lube on there.
I feel like there's very few companies doing eyelided
Yeah,
rims really anymore. That's
Yeah.
kind of, now that extrusions have improved enough and materials have kind of evolved to where they, it just
Spoke
isn't.
bag thicknesses are getting a little bit more robust.
Yeah,
Yeah.
it's just gotten better, to
Yeah.
where it's not really a necessary thing.
You
It's
don't
just,
see, rim outside flare at each spoke nipple.
Yep.
point
No, yeah.
like you did when you had 290 gram rims and
Mhm.
36 spokes
Yep.
and soft aluminum rims.
yep.
Another place where a drop of oil comes in handy is if spokes where they cross,
They notch.
they
yeah.
can rub against each other,
Yeah.
and it creates a really annoying noise, and a drop of oil at that crossing, and you squeeze them a couple of times and that goes away.
I've sent customers out with little bits of plastic,
Yeah.
credit card like plastic at each crossing and say, do you hear the ticking now? No. Okay, well, that's the source. The
Yeah,
spokes are
that's
going
right.
Up and out of the notch.
That's a really easy problem to solve.
Yeah.
Yes?
Getting on that crossing, Schwinn used to build their wheels without the spokes touching. There's a gap.
Yeah, interlacing's a bit hot
We
topic right
touched
now.
it. Why and
So,
why aren't we doing it that way anymore?
interlacing's a hot topic right now, and people, pros and cons against and for. I interlace on that last cross in my brain, how my brain works and how I've ridden, particularly because I ride mountain bikes a lot more. When you have that wheel on edge, it just gives you a little bit more of that lateral stability. So I do cross there, and when the wheel is tensioned properly, it shouldn't move as much. A lot of times you'll hear that noise on the non-drive side, where it's a lot less, and typically on a road bike, where those hub flanges are a lot narrower, we don't have that nice wide base of a boost or a super boost hub. I don't know if there's one right answer on that question, and I think all the opinions are valid. For myself, I interlace.
I think a lot of it is just because it's always been done that way.
Yeah.
But from a structural standpoint, there's not a whole lot to back it up. I did quite a bit of experimentation on that. If you look at, Park put out a short video just recently on that topic, and I told him I agree with him. They just showed that there's not particularly any benefit. So if you think of a spoke when it comes into the bottom of the load-bearing zone, its tension goes down, right? The idea of a crossing spoke is partly that that's another spoke can help absorb that. Maybe it'll say, here, I'll take a little bit of that decrease in tension so yours doesn't go down as much. The problem with that theory is that if you look carefully at it, you see that the spoke that is crossing this one is always the very next one in line to go through the bottom of the load-bearing zone itself. So its tension is already starting to go down. When this one is at the bottom and it's gone down the most, this one is already starting to lose some of this tension. So it's already in a poor position to sort of help out with this one. So I think that a lot of wheels are not crossed, and I think it depends a lot on the situation. So if you look at a completed wheel where the spokes come out of the hub, there's a triangle there. And the smaller the triangle, the more the spokes have to change orientation to get around another one. You don't want to have a lot of spoke deflection in the wheel just to be able to get around and cross another one and lace with it. So I think it's very situational dependent. I don't think there's ever going to be agreement on it. But I think I can see both sides of it. And the experimentation I've done clearly shows that there's not as much benefit as people assume that there is, which doesn't mean that there isn't any. Yes.
Do you feel that the type of biking that you do plays a big part in your wheel building skills, like mountain biking to road and such?
I think so, and I mean, I just enjoy riding bikes, so I ride all bikes. But that does have a bearing, I tend to build my road wheels a little more robust because I have a mountain biking background. It's just, and I've ridden, 24-hole wheels on really rugged stuff, and they've come through just fine. I would say that, your background always, gives weight to what you do. But in the end, a strong built wheel is a strong built wheel. Do we lessen up on a road wheel a little bit? Yeah, because, you're not coming, 4 feet out of the air onto it, hopefully. So, and you're not, those bikes aren't leaning over as far, so you can get away with a little bit less. But as rim, the biggest thing for me is the rims have gotten so much better, even in the last 10 years, that we can get away with, a lot less. So even now you see, where 32-hole used to be, the standard for mountain biking, a lot of them are now 28-hole, because those rims are so much better. So, I don't know if that answered your question.
Yeah.
Sorry.
I mean, it helps you, it helps you relate when you're dealing with a customer, that you can be like, yeah, I've got this experience in doing this, so, you can kind of, like I say, kind of just relate to what they're needing and maybe understand exactly what they're asking for, whereas if somebody's doing a discipline that you really don't participate in and they come at you and you're just kind of like, I don't know what you need, like you'd come at it a little less.
So would you suggest, because I'm mountain biking and city biking, would you suggest kind of learning other biking to know what your customer may need?
Bikes are fun, just go ride.
It doesn't, yeah. It's a great excuse to buy more bikes.
Yeah.
Riding because it's fun.
Yeah.
Did you see outside? It looked like they were trying to give us a time situation.
Okay.
They were at the door. They were at the door doing some sort of gesture. This is my interpretation of it. I could be wrong.
Hopefully it wasn't, what kind of a gesture was
It
it?
appeared to me as a "you're going too long" gesture, but again, this is just my interpretation.
Okay, all right. Thank you very much.
Thank you all for coming.